Hey, welcome back. I'm Corey, and we're about to get started on day 4 of Advent of Code in Rust. If you missed the previous days, check out the playlist up top for all my solutions. Let's get started. Okay, let's dive right into number 4. 4. Camp Cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up sections of the camp. Each section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated efforts, the elves pair up and make a big list of the section assignments for each pair. Your puzzle input. For example, consider the following list of section assignment pairs: 2 to 4, 6 to 8, 2 to 3, 4 to 5, 5 to 7, 7 to 9. For the first few pairs, this list means within the first pair of elves, the first elf has assigned sections 2, 4, 2 to 4, while the second elf has assigned sections 6 through 8. The elves in the second pair were each assigned 2 sections. The elves in the third pair were each assigned 3 sections. One got sections 5, 6, 7, while the other got 7, 8, 9. Okay. Their example list uses single-digit session IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pairs of section assignments look like this. Okay, sure. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2-8 fully contains 3-7, and 6-6 is fully contained by 4-6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So these seem like the most in need of reconsideration. In this example, there are 2 such pairs. And how many assignment pairs does one range fully contain the other? Okay, so a lot of this is going to be parsing, or maybe not a lot. Maybe the parsing is not going to be too bad, but here's the example input. So let's copy that, and let's get started. So cargo new, we're going to do a library again. I liked that from last time. Camp cleanup. Okay, let's add that to our cargo toml for our workspace as well. cd to 04, cargo test. Awesome. Let's go to our camp cleanup. Okay, and again, we just have our add function that it gives us and our it works. So let's change this to example input part 1. And what we want to do here is let input equal include string example input. Let answer equal part 1 of input. This is basically exactly the same as we've done in previous weeks, or I guess just last week for this style. An answer here is 2. There's 2 of them that do this. So let's add our example input file. And then the other thing we need to add is, let's change this to our part 1 method, which takes in an input of a string and returns a U64. We've been using U64s for all of our numbers so far. And let's run the test like this. There we go. Still is gonna fail on not yet implemented from our to-do, but that's perfect. Okay. Okay, so we want to parse. We have 2. What is this? This is an assignment. And then we have a pair of assignments on a line. Okay, so let's make an assignment struct, I think. I think that might be the right level of a struct assignment. Yeah, that'll work. From a U64, and then to a U64. Okay, so then what do we want? This is like a pair of assignments. So like I don't really know where I wanna I guess let's just do a pair. Let's make a struct pair which has a left assignment and a right assignment. Basically just doing this so that I can have a nice place to implement a parse method. Function parse takes our input, returns a pair. So if we do this, we say we are going to get a line. So I think we're going to split on a comma. And then on each half, we're going to do assignment parse, which doesn't exist yet, but that's okay. And then this is, let's do let a p equals, can I do this as, I don't know, let's find out. Can we just collect it to a tuple like that? That is supposed to be an equal sign. I'm gonna go with no. Oh, well, I also don't know. We also don't have this method, so let's do this first. Assignment, function parse, input goes to itself. Input dot split, and we're splitting on a dash. And then we're gonna map this into, I think it just has a parse method that returns a U64. Consider using this to float. No, but there is just a sf.parse as a U64 and unwrap it. We're gonna say we know the thing's gonna be a number. Okay, so now we have let p equal I'm not sure why it's p. Let's have this be a vec. Let's just collect this to a vec because that'll be I know that'll work. Okay. Parse U64 U64. There we go. Okay. And then self is 2 equals split at 0, and then oh no, it's from and then 2 split at 1. Okay. We can do another one of these like debug assert equals. I liked that before, so that we do split dot length is equal to 2. We only, if we got 3 segments here, our parsing must be off. We got 3 segments. Yeah, that's fine. Okay. Now we are gonna basically do the same thing up top. Instead of trying to do this, we're just gonna go to a vec. And then we'll do a self is a left is p at 0, and the right is p at 1. I think that will work. Can't move out of index because the value. Okay. So what's telling me is assignment doesn't implement copy, and these are references. So I probably could clone them, and that's probably what we should just do. Except they can't do clone because we haven't told them that they can be clonable. We also do want debug, the one that they were just recommending as well. So let's go ahead and add that. Now we can clone this. I'm gonna add clone and debug to our pair as well, because I think we're gonna want to debug parse these out in just a second. Let's take this exact same message up here. We have two parts. Oh, if we got anything but 2, because it's not about just getting 3. Oops. Okay, so we should now be able to parse our input, I think. So let pairs equal pairs, which is a vec of pairs, equal input dot lines dot map pair parse dot collect, and then debug pairs. Reference to it just in case I want to do something with it in a second, and to do. No, we're returning the to do. Okay, run the test. Split.lang. Okay, so line 12. What did I do up on line 12? Oh, I just changed the variable name. Run test. And we should get a debug out of our pairs. Awesome. So the pair has like the left and the right assignment, and each assignment has the from and the to. Okay. So let's write the method that we need now. So on pair, we want a function called either over is overlapping. We'll just call it is overlapping. And it takes a reference to self. And it's going to be self dot left contains right, or self dot right contains left. And then function left contains right on self. Oh, this returns a Boolean. I forgot the return type up here, which is a Boolean. Left contains right, and then we also want right contains left. So left contains right if self dot left dot from is less than or equal to self dot right dot from, and self dot left dot to is greater than or equal to self dot right dot to. Oops. Okay, so this is just saying, okay, it wants it all in one line. That's fine. If the left is bigger than the right, the from is, if it's fully contained on the from side and fully contained on the to side. So now I want basically the exact same method, but backwards for this one. And I'm actually just gonna go right and left and right. Oops. Right. Right. Left. Okay, so now we have the is overlapping methods, and that's actually pretty close to all we need here, I think. We're gonna stop going to a vec because we'll keep it as a vec for right now. And the answer here is just pairs dot iterator, to go to my iterator, and filter for pair is overlapping dot count, filter dot length, I think. Pair is overlapping. Why did the oh, expected function found signature. Why is that? Found function signature for R. It expected a reference. We already had a reference. Why does it found function expected function signature reference to a reference? Okay, well let's just try this way then, I guess, right? p dot is overlapping. And then like count. It actually isn't going to be a U64 this time because what we get out of the iterators is actually a U size. So let's just make it that because I think that's gonna be fine. Oh cool, there we go. Our example output passes. So let's get our my input. New file, my.input. Get puzzle input. There we go. And let's set up the test. Make this my input file. It's not going to be 2, but we will use it to figure out what the answer is. The answer should be 444. That's fun. 444. There we go. Okay, part 1 done. Let's update the test file here. And let's make sure all of them are passing. And by all of them, I mean the 2 parts we have. Awesome. Day 4, part 1. Nice, that one was pretty quick. Let's see if part B is, or part 2. It seems like there is still quite a bit of duplicated work planned. Instead, the elves would like to know the number of pairs that overlap at all. In the above example, the first 2 pairs, 2, 4, 6, 8, and 2, 3, 4, 5, don't overlap, while the remaining 4 pairs do overlap. Okay, so we just want to count the number of overlapping pairs, not fully overlapping like before. Which might mean that we want to change some of our naming around. Because we have is overlapping, and what I think we want to rename this to is fully contained. And that is, yeah, left contains right or right contains left. It is fully contained. So there we go. That's just a little bit better naming here so that we can have a is overlapping that does not mean that. Okay, so function is overlapping. And I think it's going to look a lot like the other one. So if it is overlapping, it's left overlaps right, or self.right overlaps left, or self.is fully contained. Because what we're going to do here is we're going to have the left overlapping is going to be here. Let's see if I can draw this out once I get the signature written. Left overlaps right is going to be going to return returns a boolean like all of these to do. Okay. So we're going to have like left and then right. That one will be this overlaps. This does not overlap on the left to right border, on the border. So yeah, that was just an example to try to, and so that's why I would need the overlapping, because I need to care about where they have a border that's right next to each other, where there's a border on the opposite side, or both of the containments. So both of the containments are covered by is fully contained, and we need to write the overlaps here. So if it's like this, if self.left.from is less than or equal to self.right.from, that gets these two positioned correctly. That means R could go all the way over to here to still be overlapping on this end, which is fine. And self.left dot 2 is strictly less than self dot right dot 2. Because if they're equal again, then we're just fully overlapping. And so we'll hit those conditions. So we can do strictly. Actually, I don't really know if I need it to. Wait, left from left to right to. Left from left to is greater than. Ah, gotcha. And this is less than or equal to. Yeah, okay. That does make sense. And let's then do the other one here of right overlaps left. Right overlaps left, where the right from is less than. Actually, I guess I do want to draw this one out as well. Let's get rid of those just because I think it makes the example better. Okay, so we want a space left and that. This is what we're looking for here. So the from for the right side is less than or equal to the from the left side. And self dot right dot 2 is less than or equal to self dot left dot 2. Okay, right overlaps left, and then is overlapping. So part 2 is part 1 with a new method. Part 2, and it's not is fully contained, it is overlapping. And I think then with our example, it's supposed to be 4. Example part 2, not part 3, and part 2. And this is now 4. And we run the test. And we got 6, so I think we probably messed up some of the logic just a touch. So let's take a look at why. Because in this example, the number of overlapping assignment pairs is 4. And does that make sense with our example? 1, 2, 3, 4, 5, 6. So I said all of them. One sec. In the above example, the first two pairs, 2, 4, 6, 8, and 2, 3, 4, 5. Oh, 2, 4, 6, 8. Yeah, okay, so those ones definitely do not overlap because they just share no bounds or anything. Okay, but I definitely said they do, so that's interesting. Filter for is overlapping. Left overlaps right if the left 2 is less than or equal to the right 2. Yeah, so that means, okay, so let's just write out the test for, let's write a unit test for this a little bit more. Function, so this is test overlapping none. So we have a the left equal, what is our example? It's 2, 4, 6, 8. So the left is a assignment from 2 to 4. Oops. And the right is from 6 to 8. Open let pair equals pair. I probably could have just parsed this from the strings. Wow, that would have been such a better idea. Okay, and then assert equals pair dot is overlapping false. Test, and it's gonna tell me that it failed, which is reasonable, probably because it got true. So is overlapping, it thinks this is true here. Assert that it's pair dot left overlaps right. It's not that, and it's not right overlaps left. And I guess just to keep going, I can do assert left contains right and right contains left. We can do all of them. This wants me to turn it into an assert. Oh man, wow, it did it, but it didn't actually keep it. It just dotted it. That's unfortunate. Assert bang. Okay. Now let's run this and see which line number it breaks on. It's gonna break on 124. Okay. Left overlaps right. Okay, so we're trying to say, so the left from is 4, 2. 2 is less than 6. Yep. Oh, okay. And self dot we need this part. We can't have right be here's the counter example that we're doing right now. This does not overlap, and this is what I need to encode right now. I need to say that the left or the right from self dot right dot from is less than or equal to self dot left dot 2. And so then this over here does but with lefts and then rights over here does not overlap. So for that we need to say that and self dot left dot from is less than or equal to self dot right dot 2. Because these ones both compare from to from, 2 to 2, and this compares from to 2, from to from, 2 to 2, from to 2. Okay. Okay. Oh, what? Did I, like, not write these as comments or something? Wait, what did I do here? I'm not trying to reference that. 61. Why? I didn't mean to refer to those as variables. What's going on? Can't find value. I'm not trying to, like, these were just comments. Okay. Not sure what was going on with those comments, but it did not like that at all. Okay, so now part 2, examples passing. Is this passing too? Yeah, wait, is everything passing? Yep, yep it is. Okay, awesome. So the example part 2 is working. Let's see if my input part 2 is gonna work. My input part 2. My input part 2 gives us an answer of 801. 801. There we go. Awesome. 801. Let's commit that. Day 4, part 2. Commit anyway. We're just doing all this on the main branch for this. And let's push it up. And there we go. Day 4 of Advent of Code solved. Thank you for joining me today. I hope you had fun. I have been really enjoying making these videos. If you liked this video, please give it a like and subscribe to my channel to see when I post the next one. Day 5 will be coming at you soon. Thanks. Bye.